In this example, we need to find two numbers that multiplied give you 12 and add up to -7. So these numbers are 3 and 4. But the result, when you add these, you get +7. So they both need to be negative. So -7. My options are x. My factors are x minus 3, x minus 4. And I'm super done. The next one, the second example is we also need to factor, and we need to get two numbers that multiplied give you 22 and add up to 13. So these options are 11 and 2, both positive. So we get x plus 11, x plus 2. Let us continue with number 3. Factor 5z squared plus 7z plus 2. So for this, remember the steps we followed. The first step is to multiply the first and the third, which is 10z squared. And then we need to split this into two numbers that multiplied give you 10z squared and add up to 7z, so that we can rewrite the second term. So we can rewrite it as 5z positive and 2z and add up to 7. So we bring down the first and the third, and we factor by grouping. So in the first two binomials, first pair of the binomials, we have 5z is the common term that multiplies z plus 1, plus we have in common the 2, z plus 1. We have in common z plus 1, and we complete the factoring 5z plus 2 with these two, remember? And we are super done. The next one is it's a binomial. So we notice that 36 is actually 6 squared and y squared is a square, a perfect square. So how do we factor this? Using the conjugate binomials. 6 plus minus y. Done. 5, we notice 4u squared minus 25. This is actually also a perfect square, 2u squared minus 5 squared. So we are going to get by conjugate binomials as well. 2u plus minus 5. Super done. Next, we need to subtract these algebraic fractions. They have the same denominator. So we just add the numerators. 2c minus 16 over c minus 8. This is equal to, and then denominator, we cannot simplify, but in numerator we can. We can factor the 2, we multiply c minus 8. And then we notice that we can eliminate c minus 8. And we get, as a result, 2. And we're super done. Next, we also have an addition. Well, now we have an addition of algebraic fractions with the same denominator. So the denominator is the same. So we are going to add only the numerators. So we have like terms, b's and numbers. B's 9b plus 5b is 14b. The denominator, we leave it as is. And then -5 plus 3, -2. So let's see what we can factor. We have in common in the denominator, in the numerator, sorry, just the 2 that multiply 7b minus 1. And then in the denominator, we have 4b. Okay, so 2/4, we can simplify it as 1/2, correct? So 7b minus 1 divided by, it's like dividing both by 2. Denominator and numerator by 2. So we get 4 over 2, 2. And the b stays as is. And this is my final answer. We continue. Number 8. Let me erase this. And we have the same thing. We can c plus 6. It's denominator, the common denominator, c squared minus 2c plus 7c minus 6. In the numerator, we get c squared plus 5c minus 6. C plus 6 equals, we need to factor the numerator, and we get two numbers. We need two numbers that multiplied give you -6 and add up to 5. So these numbers are +6, -1, because when you add these, you get 5. So these are c plus 6, c minus 1. We can eliminate the c plus 6, and we are left with c minus 1. And this is my final and simplified answer, because remember, in these cases, we need to simplify our answer as much as possible. Number 9. We are pretty much doing the same thing. We have in the denominator, we will get y squared minus 8y plus 16, because it's our common denominator. And in the numerator, we get a y squared minus 3y minus 4. Here we have a minus. And then we're going to factor. We're going to continue here. We're going to factor out whatever we can. In the numerator, we have to think of two numbers that multiplied give you -4 and add up to -3. These are easy because -4 and 1, they work. -3, there you go. So it's -4 plus 1. In the denominator, we need two numbers that multiplied give you 16 and add up to -8. So these numbers are 4 and 4, correct? But negative. So -4, -4. So we can eliminate one factor, y minus 4 factor, and we get y plus 1 divided by y minus 4. And we are super done. We continue with number 10. Again, here we have, it looks like a difference of squares, but remember what I told you. Before we even start to factor, we need to check if they have something in common. They do. They are both multiples of 3. So we can factor the 3 out. So 3 that multiplies 12. 12. Oh, no, I'm missing something. 36 and 9, what's the greatest common factor? It's actually 9. So we can factor the 9 out, and we get 4 minus z squared, correct? How do you know you're correct? 9 times 4, 36. 9 times -c squared, 9z squared, -9z squared. So now the inside is 2 squared, and the c squared is c squared. So we're going to use a two binomials to conjugate binomials, right? So one of them will have the 2, another the 2, plus minus z. And we are super down. We have factored completely. We continue with this rationalization. If you recall, we need to multiply by the denominator, by the conjugate binomial, which is now with positive. And we have to remember that. We do this because we want to get rid of the square root in the denominator. That's the point of rationalizing. So because when you multiply binomial by its conjugate, I wrote it a minus b, correct? That is correct. So we get a difference of squares, which you just learned in a few problems ago. So we need to multiply in the numerator the 4 multiply 7 and also the 3. The 3, right? The square root of 2. So we get 28 plus 12 square root of 2 divided by the square of the first is 7 squared 49 minus 3 square root of 2 squared is actually 3 squared times square root of 2 squared. So 3 squared is 9, square root of 2 squared is 2. So we get 18 in the denominator. 49 minus 18. So this answer is not done. It's not complete. 28 plus 12 square root of 2 divided by 49 minus 18. We get 1 and we get 3. 31. So if you notice, 31 is a prime number. So we cannot factor this anymore. So we have to stop there, and that is my final answer. We continue with this subtraction, sorry, this fraction that involves radicals. So in this division, we also have to multiply by the conjugate binomial, which is square root of 11 minus square root of 5. Remember this, but with the negative, with the opposite, right? So square root of 11 minus square root of 11. Let me make this better. Square root of 11 minus square root of 5. In the numerator, we will get 3. Let me write it over here. So we are gonna have 3 square root of 11 times square root of 11 is 3 times 11. And then 3 square root of 11 minus square root of 5. Square root of 11 and square root of 5, they have nothing in common, so they can go together. We are using these formulas. Square root of a, square root of b, square root of ab. And then we have minus 3 square root of 55. And then we need to multiply. I'm going to change the color for this. We need to multiply this by this and also this by this. And then go back to blue. So we have negative square root of 55. Negative times negative, it's positive 5. And the denominator is easy. It's just the square root of 11 squared, which is 11, minus square root of 5 squared, which is 5. So we get 3 times 11, 33. Negative 3 square root of 55 minus 1 square root of 55 is negative 2 square root of 50. Oh, sorry, negative 4, because these are both negative. So we get negative 4. I'm going to write it in a better way. Square root of 55. And then plus 5. Divided by 11 minus 5, 6. We can simplify this more if we add 33 plus 5. 38 minus 4 square root of 55. Divided by 6. Now, apparently we are done, but if you notice, all of them are divisible by 2. So 38 divided by 2, 19, minus 4 divided by 2 is 2, 55, divided by 6 divided by 2, 3. And now we're done. This is my final answer. It's a little long, but we're done. We continue with the order of operations. If you recall, we have a keyword, the PEMDAS. So here we need to get rid of this parentheses and then use the exponents and so on. So we start with that, with whatever is inside the brackets. These are the brackets. So we get 13 minus 8 is 5 times 7 minus 19 divided by 8. And then we have 5 times, oh, sorry, I'll solve this right away. So it's 5 times 7, 35, minus 19 over 8. What happens inside the bracket? 35 minus 19 is actually 2 or 1, sorry. 19, I missed this. No, it's 6. 16, correct? Because 5 minus 15 minus 9 is 6. And then this becomes a 2, 2 minus 1, okay. 16, and we will divide this by 8. So it's, the final answer is 2. We continue. This one is easy. You just have to remember that when you multiply, when you multiply fractions, you just need to multiply numerators with numerators, denominators with denominators. So it's 18 divided by 24. If you see here, if you notice, they're all divisible by 2, but also by 3, which means divisible by 6. So we can divide everything by 6. So this becomes 3. And then 24 divided by 6 is 4, 3/4. And we are super done. The next one, the first part we will do up to 20. And then this is a division of fractions. So what do? We cross multiply. And this goes like this. So 7 times 10, 70, divided by 15 times 3. It's 45. If you notice here, we can divide everything by 5. So 70 by 5 is 70 by 5. Remember, we can use a calculator, but let's do it step by step. So 1, 2, 20, 14. So it's 14 divided by 45 divided by 5 is 9. And the final answer is 14 divided by 9. Okay? We are super done. In this exercise, we need to evaluate this expression. Evaluating means solving it. So 1/2, the parentheses, it's a fraction that is being squared. So it's 25 divided by 36 plus 2/9. And this is 25 divided by 72 plus 2/9. So what we're going to do here, now you can do this in the calculator, but let's do it by hand. Suppose you don't have a calculator, so we can rewrite this as an equivalent fraction by multiplying by 8, so that you have 72 in the denominators. Okay, let me go back to blue. So this becomes 25 over 72 plus 16 over 72. And the final answer is 72. And 25 plus 16 is 141. And then we are done because 41 is a prime number. We continue with 17. Okay, so this one, we have to simplify the denominator. I mean, the numerator and then the denominator, one at a time, okay? So here, remember the formula, when you have a square root of a fraction, it's the same as finding the fractions of the square roots. So it's square root of 64 divided by square root of 9 plus, in the second expression, we have a multiplication of fractions. So we get 3 divided by 48. So we have now we will simplify afterwards. In the meantime, here we have a division. Okay. So let's solve this division. So it's 9/4. And we write it over here. And then minus the same thing. Square root of 16 divided by the square root of 25. We get, let us solve this. So we get square root of 64 is 8 and square root of 9 is 3 plus 3 root 48. And then we have 9/4 minus 4/5. Because square root of 16 is 4, square root of 25 is 5. And then for the final answer, we can use our calculator to get, so we get 655 divided by 348. We cannot simplify this more. So we are done with it. We continue. This is done the same thing. This is done in the same way. So we can skip to 19. Okay. It says it's quite. Let me make this bigger so that if it's a squash club has 27 members, 19 have black hair, 14 have brown eyes, and 11 have both black hair and brown eyes. Find the number of members with black hair or brown eyes. That means you need to find the union, okay, without repeating numbers. So we need to find the following. Let's create our Venn diagram. And the ones that have black hair are here. So it's 19. The brown eyes is 14. And the ones that share this both black hair and brown eyes, there are 11. So if the total black hair is 19 and we already have 11 that share the two traits, then 8 must be the only ones that have black hair without repeating, okay? And then the brown eyes, we total is 14, but we already have 11 that also have black hair. So we need to subtract 14 from 11 and we get 3. And now we have 8 plus 3, 11 plus 11, 22. So, but 27 is the number of members of the squash club. So that means if 22 are inside the circles, the outside is 5. So this one is the do not have black hair nor brown eyes. Okay, what's what's the question? Black hair or brown eyes? Black hair or brown eyes, that means you need to add these 3. Okay, because you can add them because they are not being repeated, and it's 22. We can check. The next one is number 20. It says, Saeed is helping his classmates get ready for their math tests by making them identical packages of pencils and calculators. He has 72 pencils and 24 calculators, and he must use all the pencils and calculators. Saeed creates the greatest number of identical packages possible. Calculate how many pencils will be in each package. So the first thing we need to do is to identify or to determine what's the greatest number of identical packages possible. And that's the keyword greatest tell us that we need to find the greatest common factor of what? Of 72 and 24. So that they have the greatest number of packages. So how do we find the greatest common factor? We can use the prime factorization, and whenever one number divides both, we have to circle it. So we start with 2, we circle it because it divides 24 and 36, and then again 2, we circle it, it's 18, 6, again the 2, and this becomes 9, and this becomes 3. Now we go to 3, and then we have 3 and 1, and we can stop there. We can stop here because 3 and 1, they have nothing in common. So the greatest common factor will be 2 times 2 times 2, 8 times 3, 24. That's the greatest common factor. What are we looking for? How many pencils will be in each package? So we have 24. 24 is the packages. So what we have to do is the number of pencils, 72, we need to divide it by the number of packages, 24. So how many pencils will there be in each package? 3. And we are super done. Let's go to the second part of this practice problems final exam guide.